Unitree has shown just how far humanoid robotics can go. The G1, a 35 kilograms robot, not only withstands repeated kicks and pushes, but also gets back up on its own using a system called anti-gravity mode. Each impact is calculated in real time, as if it predicts the force and knows exactly how to respond. The secret lies in the combination of advanced sensors and motors in each joint. Depth cameras and 3D LiDAR scan the environment, providing precise data on the robot's position and the direction of the applied force. Even before touching the ground, the G1 adjusts its center of gravity, leans in the correction, or takes a lateral step, absorbing the impact and standing up within seconds. During testing, it received frontal and lateral kicks, double pushes, and even impacts while running. Each time, the movement was natural, fluid, and controlled, showing that the robot isn't just reacting. It predicts and executes the optimal recovery strategy. This capability is crucial in industrial or research environments where falls or interruptions can cost time and money. Beyond impressing, the G1 was designed to be functional. Priced around $16,000, it is more accessible than many advanced humanoids and can work in factories, labs, and other settings that require resilience and adaptability without constant human intervention. This anti-gravity mode shows that robots can remain productive even in unexpected situations without stopping after a shock. How far could other machines go in learning to recover on their own like the G1? Exoskeletons used to be heavy, expensive, and inaccessible. But researchers have created Kinethreads, a full-body suit that weighs less than 5 kilograms, costs under $500, and delivers realistic physical sensations in virtual reality. It promises to change the way we feel and interact with VR, without relying on bulky devices or six-figure prices. The secret of Kinethreads lies in the threads and motors distributed across the body. Nylon threads run through channels in the fabric, connected to small motors that act like artificial tendons. When activated, they tension and pull the muscles, guiding movement. A Raspberry Pi controls the entire system via Python scripts, enabling precise coordination between motion and tactile feedback. The suit covers the chest, arms, and legs, using elastic neoprene for comfort and rigid plastic guides to keep the threads in place. On the arms, 4 motors control shoulder flexion, elbow movement, and rotation, while wider straps on the legs stabilize the hips and knees. Additional motors provide vibration, allowing the user to feel resistance from virtual objects or impacts from explosions in the game. Despite its compact size, the system delivers up to 120 newtons of force and vibration up to 200 hertz, simulating everything from the weight of a light object to sharp impacts. All of this is packed into a modular suit, easy to put on in under 30 seconds, making high-quality haptics accessible for VR and rehabilitation, something previously limited to expensive, bulky equipment. Kinethreads shows that the sensation of touching, pushing, or feeling weight in virtual reality doesn't need to be elite technology. Imagine how this could revolutionize gaming, training, and physical rehabilitation. How far could suits like this go to make VR fully immersive? Did you enjoy the content? Then make sure to subscribe to the channel. This helps more technology grow and reach even more tech enthusiasts. On your screen, you'll find 2 recommended videos, one from our Clips channel and another from our main channel with full content and even more updates. Pick one and keep up with the latest from more technology. Thanks for watching and see you in the next video.